All right, so we're going to do 2.1 notes. We are doing the Unit 2 Systems and Matrices unit. This unit reviews systems of equations of 2 or 3 variables. Then you will explore how you can use a new tool, matrices, to solve these systems. So on page 3 in your notes, we are going to solve systems by graphing, by substitution, and by elimination. Systems of equations are a set of equations including one or more variables. Today they will have 2 variables. The solution to the system is the point that makes each equation true. So for example number 1, your school planted 2 trees when it was first opened. One tree, a ficus, was 6 feet tall when it was planted and has grown 2 feet per year. The other tree, an oak, was grown from 3 feet and has grown 3 feet per year. Complete the tables below for the 2 planted trees. So the ficus tree at year 0 started out at 6 feet tall. It grows 2 feet per year, so we're going to add 2 to get 8, 10, 12, and 14. For the oak tree, it started at 3 feet and it grew 3 feet per year, so you're going to add 3 to your table. It says using N for the number of weeks and H for the height of the trees, write 2 formulas for each of the plants. So it's the height of the tree equals. For the ficus, the rate of growth was 2 feet per year, so it's 2 times the number of years, plus starting out at 6 feet tall. For your oak tree, the height equals, notice it's growing 3 feet per year, and then it started out at a height of 3 feet. Now we have to graph both of them using the table. So we have at point 0, 6, 1, 8, 2, 10, 3, 12, and 4, 14. Draw on the line. The other one, 0, 3, 1, 6, 2, 9, 3, 12, and 4, 15. Draw in that line. So when will both types of trees be the same height? Well, that should be at year 3 because that's when these 2 lines intersect. And also it matches on the table. At 3 years, what will their height be? The answer is 12 feet. When is the ficus taller? So if you recall, this is the ficus. It is taller than the oak tree before 3 years. The oak tree then gets taller after 3 years. How would this be different if the trees grew at the same rate? They would never be the same height. How would this be different if the trees started at the same height and grew at the same rate? Then they would always be the same height. So now we're going to solve systems algebraically. There are 3 ways to do so. The first way is to graph both lines and see where they intersect. You write your point as your solution as x comma y. You can also do substitution. So if you have 2 variables that are equal, you can set the equations equal and then plug this back in to solve for the other variable. Or you can use elimination where you line up your x and y variables, add the equations and solve, and then plug this back in to find the other variable. But you should always have a point as your answer. So we're going to solve each system by graphing. So notice this has a y-intercept of 1 and a slope of up 2 over 3. And then we can draw on our line. To graph y equals 5, it's a flat line through y equals 5. So the solution is where the 2 lines cross. So they are crossing at 6, 5. So that is our solution. Make sure you put parentheses around your answer. For b, you have a y-intercept of 1, and your slope is up 1 over 3. You can do it multiple times if you want, but draw on your line. The other equation has a y-intercept of -3. The slope is up 1 over 3. Notice how that creates two parallel lines. These will never intersect, so there is no solution. For part C, if we wanted to solve for y, you have to subtract the 4x and then divide everything by 2. By doing that, you get y equals negative 2x plus 3. So your y-intercept is 3, and your slope is down 2, right 1. Down 2, right 1. Draw on your line. To get y by itself in this equation, you have to subtract the 3x and then divide both terms by negative 3. So you should get y equals a positive x minus 3. So your y-intercept is negative 3, and your slope is a positive 1 over 1. So you go up 1 over 1, up 1 over 1, up 1 over 1, and so on. Where these lines intersect is the solution, so notice that's going from the origin right 2, down 1. So your solution is at 2, negative 1. For part D, if you solve for y, you would minus the 2x and then divide both terms by 2. That should give you y equals a negative x plus 3. So you have a y-intercept of 3, and then you go down 1, right 1, down 1, right 1, down 1, right 1. Draw on the line. For this one, if you minus the x, you're going to get the same equation. So when you graph it, you're going to get the same line. So this has more than one answer, so this would be called many solutions. For this one, it says to use the substitution method to solve the systems of equations below for both variables. Notice how the variables are not lined up. So substitution is the best method for this problem, because the y value is by itself already. So we're going to circle what y equals, and we're going to plug it into the y in the other equation. This will give us x plus 2 times the y goes away and becomes 3x plus 2. And then that should equal 11. So we can drop down the x plus and then distribute the 2. So that'll give us 2 times 3x, which is 6x, and 2 times 2 is 4. And then this should equal 11. X plus 6x makes 7x. Minus the 4 over 11 minus 4 is 7. Divide by 7, you get x equals 1. Notice we're not done. We also have to solve for y. So we're going to plug this answer into this circle up here to solve for y. This will give us 3 times x is 1 plus 2. 3 times 1 is 3, and 3 plus 2 is 5. You always write your answer as x comma y. So it's 1 comma 5. For part B, this time the variable's not by itself in this equation, but this time the variable is alone here, and this time x is by itself. So let's circle what x equals, and this is going to go into the x variable in the other equation. So the x is going to go away. It's going to become y plus 3 plus 2y equals negative 6. We can combine y plus 2y to make 3y plus 3 equals negative 6. Subtract the 3, so negative 6 minus 3 is negative 9. And divide both sides by 3, you get y equals negative 3. Once you have that letter, you can plug it back into the circle to find x. So x equals y is negative 3 plus 3, which is 0. You always write your answer as x comma y, so it's 0 comma negative 3. For this one, the variable y is by itself in the second equation, so circle what y equals. This is going to substitute where y is up here. So it's going to be 2x plus, the y goes away, it becomes a negative 2x plus 4, and that should equal 6. When we combine like terms, a 2x and a negative 2x is going to cancel. I'm left with 4 equals 6. This is not a true statement. 4 does not equal 6. Therefore, this system does not have a solution. The last way to solve systems is using the elimination method. Notice in all of these examples, the x and the y variables are lined up. So in this example, notice how the y and negative y are going to cancel when I add these two equations. So that's what I'm going to do. 4x plus a negative 2x is 2x. Y and negative y cancels. That should equal negative 10 plus 14 is 4. So to get x by itself, you divide by 2 and get x equals 2. Once you know one variable, you can plug it into either one of these equations to find the other one. Notice how the top one's more friendly because it doesn't have these negatives. So we're going to plug in the 2 for x in this equation, giving us 4 times 2 plus y equals negative 10. 4 times 2 is 8. And then we can subtract the 8 over, so negative 10 minus the 8 is negative 18. And then you write your answer as x comma y, so it's 2, negative 18. Notice if you were to add the equation in part B, you would get 8x minus 2y equals 36. Neither variable cancels. But I can make a variable cancel if I multiply this entire equation on the top by 2. If I distribute the 2, I get 2 times 5x, which is going to be 10x. 2 times 2y is 4y. And 2 times 16 is 32. If I write this equation below it, notice how the y's are going to now cancel. So now I can add these equations. So 10x plus 3x is 13x. The y's cancel. 32 plus 20 is 52. Divide both sides by 13, you get x equals 4. Now to solve for y, you can plug it into either equation. It doesn't matter. Since there's no negatives on the top, I'm going to use the top equation. So that's going to go in here. So that's going to give me 5 times x is 4 plus 2y equals 16. 5 times 4 is 20. Minus the 20 over, 16 minus 20 is negative 4. Divide both sides by 2, I get y equals negative 2. Write your answer as x comma y, so 4, negative 2. For C, when you add these equations, neither variable cancels. And notice this is a little bit harder. I can't just multiply one equation to get the variables to cancel. I have to multiply both equations to make the variables cancel. And since the x's are opposite of each other, I'm going to cancel the x's. But it doesn't matter. You could multiply to cancel the y's. But since I'm getting the x's to cancel, I want them to become the same number but opposite. So I'm going to multiply the top equation by 3 and the bottom equation by 4. That will make the x's cancel. But you can't just multiply the first variable. You have to multiply the entire equation. So 3 times 4x is 12x. 3 times 5y is 15y equals 3 times 35, which is 105. For the second equation, 4 times negative 3x is negative 12x. 4 times 2y is 8y. And 4 times negative 9 is negative 36. Notice now when I add these equations, the x's cancel. So 15y plus 8y is 23y equals 105 minus 36 is 69. Divide both sides by 23, you get y equals 3. You can plug this value into either equation. Since there's no negatives on top, that's what I'm going to pick. So it's 4x plus 5 times, the y goes away, becomes 3, and that should equal 35. 5 times 3 is 15. Subtract the 15, so 35 minus the 15 is 20. And divide by 4, so x equals 5. Always write your answer as x comma y, so it's 5 comma 3. Part D is similar to C. Notice these can't cancel, nor can I multiply one equation. I have to multiply by both. So I'm trying to cancel maybe the x's again because these are opposite. That would mean I'd multiply the top by 5 and the bottom by -3. That'll make them be the same number but opposite. So the top row is going to become 5 times -3x is -15x. 5 times -4y is -20y equals 5 times 27 is 135. Bottom row, 3 times 5x is 15x. 3 times -6y is -18y equals 3 times -7 is -21. Notice how my x's cancel. -20y and -18y makes a -36y equals 114. Divide by -38, you get -3. You can plug this into either equation, which notice they both have variables, but this time the bottom one has less negatives. So we can plug it in here. So we have 5x minus the 6 becomes -3 equals -7. So -6 times -3 becomes a positive 18. Subtract the 18 over, so -7 minus 18 is -25. And divide by 5, you get -5. The answer is x comma y, so -5 comma -3.